Today's lecture 29 of basic electronics is about 3-bit triple counter. Welcome to our channel ClassFly community. So today we will deal with 3-bit triple counter, and in 3-bit triple counter there are two types, that is up one and another is down one. The difference between these two is that in the up and the down is, in the up one it is negatively triggered and in the downward it is positively triggered, that is the clock. Okay, that means there will, whatever the changes will be, this will be from 1 to 0. When the clock will change from 1 to 0, at that time there will be change, and in the down one it's just the opposite, that is it will change from 0 to 1. Okay, so this is a 3-bit ripple counter. Why this is said as ripple? Because in the 2 and the 3rd flip-flop, the previous output of the flip-flop is being clocked in the 2nd and the 3rd flip-flop. That's why it is called the ripple counter, and it is an asynchronous counter because there are different clocks in each of the flip-flop. See, in this counter, the first flip-flop will have an external clock, whereas the other clocks will be the previous outputs of the flip-flops respectively. And here the most important point is that this ripple counter works only in the toggle state, and we know that the J case toggle state is when both are 1. Okay, so see, the first flip-flop will be our LSB and the 3rd flip-flop will be our MSB. Here I have taken the mod 8 counter. So why here there are 3 flip-flops I have taken? Because it will have 3 bits. Because as it is mod 8 counter, so 2 to the power 3, so this 3 denotes the 3 bits. It will be 0 0 0 or 1 1 1. Okay, so see now how the stages will be there. First we will see that the initial will be the 0 0 0. As I told, this is the up counter, that is it will change from 1 to 0. So see, from here I am doing the same table one more time to make you clear. See, it is the initial state, this is the initial state, right? So first write like 0 1 0 1 here, 0 1 0 1 0 1 0 1 and 0. Last will be I0. Write like this. See, from 0 to 1 there will be no change, so I will write 0 only. From 1 to 0 there will be change, so I will write 1. From 0 to 1 there will be no change, so I will write 1. From 1 to 0 there will be change, so I will write 0. From 0 to 1 there will be no change, so I will write 0. From 1 to 0 there will be change, so I will write 1. From 0 to 1 there will be no change, so I will write 1. From 1 to 0 there will be change, so I will write 0. Okay, now I will shift to this row. Now I will see this from 0 to 0, so there will be no change, so 0. From 0 1 there will be no change, so 0. From 1 to 1 there will be no change, so 0. From 1 to 0 there will be change, so 1. From 0 to 0 no change, so 1. From 0 to 1 no change, so 1. From 1 to 1 no change, so 1. From 1 to 0 there will be change, so it will be 0. So you can see how I made the count value in binary in the following stages. Okay, so from 1 to 0 there will be change, and in other cases there will be no change. So our frequency divider will be f out equal to f in by 8. Okay, now we will move on to a down counter. Okay, let's move on. See, this is a down counter. Here we are using the T flip-flop instead of JK flip-flop. It is similar because this will work in the toggle state, and the T flip-flop toggle state is the 1. Whenever there will be 1, it will toggle, right? So similarly here also the first flip-flop will be LSB and the third will be the MSB. Why this is ripple? Because the 2 and the 3rd flip-flop are using the previous output clock, right? Previous output as a clock. So here the only change is that the clock is in the positively triggered. So here the changes will be from 0 to 1. So let's again do the table. So 0 0 0 is the first initial state. So first write the first column 0 1 0 1 0 1 0 1 0. Okay, so 0 to 1 there will be change. So 1. From 1 to 0 no change. So 1. From 0 to 1 there will be change. So 0. From 1 to 0 there will be no change. So 0. From 0 to 1 there will be change. So 1. From 1 to 0 there will be no change. So 1. From 0 to 1 there will be change. So 0. So as I was saying, from 0 to 1 there will be change. So 0. From 1 to 0 there will be no change. So 0. Now I will come to this part. So 0 to 1 there will be change. So 1. From 1 to 1 no change. So 1. From 1 to 0 no change. So 1. From 0 to 0 no change. So 1. From 0 to 1 there will be change. So 0. From 1 to 1 there will be no change. So 0. From 1 to 0 there will be no change. So 0. From 0 to 0 there will be no change. So 0. So I got this one also, count value in binary for the equivalent staging. So basic difference between the down and the up is that one is positively triggered, that is the down one will be positively triggered and the up one will be negatively triggered. And here also the frequency divider will be same, that is f out is equal to fn by 8. And the point to be noted is that it is an asynchronous counter and it works in the toggle mode. One more, it will be there that the first flip-flop will be externally connected to the clock, while the other flip-flops will be the output of the previous flip-flops. Okay, so I hope you all understood the 3-bit ripple counter up and the down. So till then, be happy and have a great day. Now it's the code time. Life is like riding a bicycle. To keep your balance, you must keep moving. I hope all of you understood today's lecture and thank you for watching.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.